This video is about simplifying radical expressions. And in the first few examples, we're going to use something called the product rule in order to simplify some rational expressions. And we've sort of used the product rule already. Basically, what the product rule says is that you can take the square root of, say, x times the square root of y, and this is the same as the square root of x times y underneath the same radical. And you can go in either direction with an equal sign. You can either start with two radicals being multiplied together, x times y equals the square root of xy, or you can start with the square root of xy and bring it over to this side, that's equal to the square root of x times the square root of y. So here we have two radicals that are being multiplied together, so this would be the same as the square root of 15xy. In this example, same thing, we're multiplying two radicals together. It doesn't matter what root you're taking, you can still apply this. And so this would be the same as the fourth root of, and 5 times 4 is 20, so that would be 20x cubed. You do have to make sure that you have the same roots, otherwise it would be like some of the things that we did earlier with the rational expressions. In these, we're going to use the quotient rule. The quotient rule is the same thing, only it's for division instead of multiplication. And so the fourth root of x divided by 16y to the fourth, we could rewrite this as the fourth root of x divided by the fourth root of 16y to the fourth. And we can't simplify the fourth root of x, but we can simplify the fourth root of y to the fourth. The fourth root of 16 is 2, and the fourth root of y to the fourth is y. In our next example here, we have the cube root of 2 divided by x, 8x to the ninth. And so we can separate this out as the cubed root of 2 over the cubed root of 8x to the ninth. And again, we can take the cubed root of 8. The cubed root of 8 is 2. And remember, when you're doing taking roots of variables raised to powers, you can take the power and divide it by the root. So 9 divided by 3 is 3. And so the cubed root of x to the ninth then would be x cubed. Example C. We have the square root of x to the 12th over 25y to the 8th. So separating these, we would get the square root of x to the 12th over the square root of 25y to the 8th. And you can take the square root of x to the 12th. Remember, when there isn't a root there, there's an implied 2, and 12 divided by 2 is 6. So the square root of x to the 12th is x to the 6th. And we can also take the square root of 25, it's 5. And you could rewrite that also if you want to, but you don't necessarily have to rewrite that as the square root of 25 times the square root of, y to the 8th. And so you don't have to do this part, but you can, if you want to, use the product rule. And when you take the square root of y to the 8th, that would be y to the 4th. 8 divided by 2 is 4. Okay. Now here we have a negative sign out front, so don't forget about the negative sign. And again, we can take the cubed root of the numerator, cubed root of 125x, and also take the cubed root of the denominator, which is y to the ninth. And the cubed root of 125 is 5, so we have negative 5. And we can't take the cubed root of x, so that'll stay underneath our cubed root. And then we have the cubed root of y to the ninth, and 9 divided by 3 is 3, so we have y to the third, or y cubed. Our next example here, we want to simplify these, and by simplifying it means if there's a perfect square that divides 48 evenly, we want to factor that and then use the product rule so that we can take the square root of that perfect square. And if you can think of the perfect square that divides 48 evenly, then you can do that right away. And 48 is 16 times 3. And then if you apply the product rule to that, it would be the square root of 16 times the square root of 3. And we can take the square root of 16, it's 4. And then you can't take the square root of 3, so that just has to remain. So we get 4 times the square root of 3. Use the product rule again. We have the square root of 16x cubed, so that would be the square root of 16 times the square root of x cubed. Square root of 16 is 4, and we can simplify this. There are a couple of ways that you can think about this. One way would be to write this out, or to think of it as x being multiplied to itself 3 times, and for every 2 that are underneath your square root, you can pull 1 out in front. And then that would leave this x remaining underneath your square root. The other way to do that would be to take your index, which is 2, the square root, so it's a 2, and divide that into 3. And 2 goes into 3 one time, and then you would take 1 times 2, gives you 2, and then you subtract, and 3 minus 2 is 1. So this is the number that you can pull out, and this has to stay underneath. And so the square root of x cubed would be x times the square root of x. Here we have the square root of 90, x to the 7th, y to the 8th. And we can rewrite this, so we have 9 times 10, and then x to the 7th and y to the 8th. And then you can separate them. Square root of 9 times the square root of 10 times the square root of x to the 7th times the square root of y to the 8th. And we can take the square root of 9, it's 3. We can't take the square root of 10, so that's going to end up staying underneath our square root. And we can take the square root of y to the 7th. It's not a perfect square root, but we can pull some of those x's out. So again, you can write a row of 7 x's and see how many you can pull out, or just do that division. So this is a square root, so there's a little implied 2 there. So we would be dividing 7 by 2. And 2 goes into 7 3 times, and then 3 times 2 is 6. And when you subtract 6, you get 1 left over. So this is how many you can pull out, and this is how many has to stay. Okay, so when we simplify this, we would be able to pull out x cubed, and then we can't take the square root of the 10, and we still have this one remaining x left underneath here, so we'll write those there. And then you can take the square root of y to the 8th, it's y to the 4th. So our final answer then is 3x cubed y to the 4th times the square root of 10x. And our next example here, cubed root of x to the 4th. So this is just simply, we need 3 x's underneath to pull 1 out. Or you can think of doing this division. So we would take 3 and divide it into 4. 3 goes into 4 one time. 1 times 3 is 3, and then you subtract that, leaving you with 1. And so that's what has to stay in, and this is what you can pull out. And so that would be x times the cubed root of x, because we can pull 1 out and 1 has to stay in. Whoops. Next we have the cubed root of negative 24, x to the 8th and y to the 10th. So we have the cubed root of negative 24 times the cubed root of 8 times the cubed root of 10. And 24 is 8 times 3, so we would write that as the cubed root, and I'm going to use the negative sign with the 8 because we can take the cubed root of negative 8 times the cubed root of 3, and then times the cubed root of y to the 10th. Oh my gosh, I forgot my y. And so the cubed root of negative 8 is negative 2. And we can't take the cubed root of 3, so that's just going to stay there in the cubed root. And we can take the cubed root of 10, so we would do that division, 3 into 10. 3 goes into 10 3 times. 3 times 3 is 9, so we're going to subtract 9 and get a remainder of 1. So this is what has to stay under, and this is how many come out. So that's going to be y cubed, and then underneath our cubed root, we still have this 3, and we had a remainder of 1 here, so we still have a y left. So why don't you go ahead and give this one a try. The fifth root of negative 32x to the fourth y to the 10th. Pause the video, and then after you complete it, turn it back on and see if you were able to get it correct. So rewrite this. Fifth root of negative 32 times the fifth root of x to the fourth times the fifth root of y to the 10th. We can take the fifth root of negative 32. Odd roots, remember you can take the odd roots of negative numbers, and if you multiply 2 to itself 5 times, you get 32. So that would be negative 2. And then there's only 4 x's underneath here. You need 5 to get even 1 out, so all 4 of these are going to have to stay underneath the fifth root. And if you divide this 10 by our root 5, you get 2. So that would be y squared. And then don't forget that you still have that x to the fourth underneath your fifth root that you couldn't simplify. Next, we have x to the seventh, y cubed, the square root of that, divided by the square root of xy. So whenever you see these, you want to write this underneath one big square root. So x to the seventh, y cubed, divided by xy. So we want to do this division and then simplify the square root after that. X to the seventh divided by x is x to the sixth, and y cubed divided by y is y squared. So we have the square root of x to the sixth y squared, and the square root of x to the sixth is x cubed, and the square root of y squared is y. And in order to put this all underneath the same root, you have to make sure your roots are the same. They were in that last example, and they are here as well. So we have the cubed root of 40x to the fifth y to the ninth divided by the cubed root of 5x squared. So we're going to do this division underneath the same cubed root, 40x to the fifth y to the ninth divided by 5x squared. And 40 divided by 5 is 8. And x to the fifth divided by x squared is x cubed. And then we have y to the ninth. And this is the cubed root. We can take the cubed root of 8, it's 2. And the cubed root of x cubed is x. And the cubed root of y to the ninth is y cubed. So 2x y cubed is our final answer. Next, we have the square root of 50x squared divided by negative 5 times the square root of 25x to the negative second. So when there isn't a number in front of either a radical or a parenthesis or a variable, there's always an implied 1. So you can imagine that there's an implied 1 right there. And so the number that we have in front of our radicals is 1 divided by negative 5. And so that's going to be negative 1/5. And then we're going to write this as one radical, 50x squared, and then divided by 25x to the negative second. So we have negative 1/5, and 50 divided by 25 is 2, and x squared divided by x to the negative second, so when you are dividing, you subtract exponents, so that would be 2 minus a negative 2, so that would be x to the 4th. And we can't take the square root of 2, so that's going to end up staying underneath our square root, and we can write this in one of a couple of ways. We can write negative 1/5, and again, the 2 is going to have to stay underneath our square root, but we can take the square root of x to the 4th, it's x squared. So you could write it like this, or you could write negative x squared times the square root of 2 all over 5. Either one of these ways is okay. And this negative sign could be on top, you could have it on bottom or out in front. Okay, our next example is the 5th root of 729x to the 9th y cubed divided by the 5th root of 3x squared y to the negative 7th. So we're going to write this underneath the same root. So 729x to the 9th y cubed divided by 3x squared y to the negative 7th. And 729 divided by 3 is 243. And x to the 9th divided by x squared is x to the 7th. And y to the 3rd divided by y to the negative 7th is going to be y to the 10th. Remember, you have to subtract your exponents, and 3 minus a negative 7 is the same as 3 plus 7, or 10. So now we need to see if we can take the 5th root of 243. So you can check the divisibility by 3 just by adding up the digits. So 2 plus 4 is 6, and 6 plus 3 is 9, and since 9 is divisible by 3, I know that 243 is divisible by 3. 3 goes into 24 8 times, and nothing left over, and 3 goes into 3 once. So it's 3 times 81, and 81 is 9 times 9, and then the 9's both factor is 3 times 3. So this is the same as 3 to the 5th. So we have the 5th root of 3 to the 5th, x to the 7th, y to the 10th. And the 5th root of 3 to the 5th would be 3. And 5 goes into 7 one time, so we can pull one x out. And 5 goes into 10 two times, so that would be y squared. And the only thing that we couldn't pull out, so we pulled out all 5 of the 3's, and we pulled out all 10 of the y's, but we still had a remainder of 2 for the x's, so we would have x squared left underneath. Okay, that finishes this lecture, so if you have any questions, let me know. Thank you.